mathematics learners. I'm teacher Rosaline. In today's lesson, we're gonna learn more about relation and function. What is the difference between the two? How will you illustrate the relation and function? We will cover also the concept of dependent and independent variables. How will you determine or differentiate these two variables? I will not keep any longer. Come with me and let's get started.
Relation and function. In our day-to-day life, there is a lot of relationship, like the relationship between the father and the mother. Similarly, the relationship between the teacher and the student. The number of hours of the employee worked to the monthly wage of the employee. The water bill paid for the month to the number of cubic meters of water consumed. These are the very good examples of relationship. In math, it is basically something that relates or connects one set to another set in a particular way. A set is a group of collection of things or often a collection of numbers. A set collection of other things like letters, names, or just about anything. Sets sometimes shown visually like this. For example, we have the first set. The elements are 1, 2, 3, 4, 5. And the second set, the elements are A, B, C, D, E. But more often you see sets written in using math notation, where all the members of the sets are put inside in the brackets. Set is just a collection of things, and a function relates to one set to another set. But how exactly does it do that? Well, to understand how function work, it will help to start naming the two sets, that is input set and output set. A function is something that it takes each value by the input set and relates it or map it to the value of the output set. For example, we have the input set, the element is 1, corresponds to the output set element A. 2 corresponds to B. 3 corresponds to C. 4 corresponds to D. And 5 corresponds to E. The input and output set refer to by a special math name. Input set is usually called domain and output set is range. We can also do function table. It is normally have two columns, one on the left for the input's value and one on the right for the corresponding output value. For example, let's say, for the input set, the list of the common polygon and the output set is the number of sides. This function is simply relates the name of the polygon to its number of sides. And the input set, that is our domain, or X, output set, that is our range, or Y. But how will you know if the relation is a function or not? Let's have an illustrative examples. Given two sets, we have the first set, the elements are 1, 2, 3, 4. And the second set, the elements are 3, 4, 5, 6. Let us do the mapping. 1 corresponds 3, 2 corresponds 4, 3 corresponds 5, 4 corresponds 6. So we have the ordered pairs of 1, 3, 2, 4, 3, 5, 4, 6. Since each element of one set is paired with exactly one element of the other set, this is an one-to-one correspondence. Let us have more example given two sets. We have the first set, the elements are 0, 1, 2, negative 2. And the second set, we have the elements of 0, 1, 4. Let us again do the mapping. 1 corresponds to 0. Rather, 0 corresponds to 0, 1 corresponds to 1, 2 corresponds to 4, negative 2 corresponds to 4. And we have the ordered pairs of 0, 0, 1, 1, 2, 4, negative 2, 4. Since there are two elements in the input set to one element in the output set, that means this is many-to-one correspondence. These two examples are a function. Let's have another examples. So we have given two sets. The first set, the elements are 1, 9, 5. The second set, the elements are 1, negative 5, 5, 0. Let us do the mapping. 1 corresponds to 1, 9 corresponds to negative 5, 9 corresponds to 5, 5 corresponds to 0. And we have the ordered pairs 1, 1, 9, negative 5, 9, positive 5, 5, 0. Since we have one element of the input set related to two elements in the output set, that means this is an one-to-many correspondence. Let us take a look at another example. We have given two sets. The first set, the elements are 1, 2, 3. The second set, the elements are 4, 5, 6. Let us again do the mapping. 1 corresponds to 4. 2 corresponds to 4. 3 corresponds to 5, 3 corresponds to 6. And we have the ordered pairs 1, 4, 2, 4, 3, 5, 3, 6. Since there are two elements in the input set related to two elements in the output set, that means this is many-to-many correspondence. And these two examples are not function. Based on the examples given, how will you define a function? A function is a relation where each input has only one output. And it is also a relation in which no two ordered pairs have the same first element, or a function associates each element in its domain with one and only one element in each range. But how will you define a relation? So it shows a relationship between two values. Let us more have an examples for relation and function. Tell whether the relation is a function. This time, given the ordered pairs 6, 3, 9, 4, 3, 0, 4, 6. Let us find first the domain, but the domain is the set of values of x, or that can be input values into a function. So the domain here, we have 6, 9, 3, 4. How about the range? The range is the set values of y that can be output values into a function. So the range here, the elements are 3, 4, 0, 6. Let us do the mapping. We have 6, 3, 9, 4, 3, 0, 4, 6. Since this is one-to-one correspondence, that means it is a function. Let's have another one. So the ordered pairs are 10, 5, 1, 4, 3, 7, and 1, 6. Let us find the domain. We have 10, 1, and 3. And we also 1. Since there are two elements of 1, that means we write it only one element on the domain. So range, we have 5, 4, 7, 6. Let us do the mapping. We have 10, 5, 1 corresponds to 4, 3 corresponds to 7, and 1 corresponds to 6. This is not function. Why? Because we have two elements in the domain. Based on the definition of the function, no two ordered pairs have the same first element or domain. What if the given is a graph? How will you identify if it is a function or not? You will use the vertical line test. For example, we have given graph. Let us draw that vertical line. So since there is only one point intersect, that means this is a function. Let's have another one. Let us draw the vertical line. And since this time, there are 2 points intersect on the graph, so that means this is not a function. So what is the vertical line test? It is a test used to tell if the graph is a function. You will draw the vertical line and see how many points it touches on the graph. If it is only ever touches 1 point, the graph is a function. Let us more have an example. Tell whether the graph is a function or not using the vertical line test. So given the first graph, Let us draw the vertical line. So since there are 2 points intersect on the graph, that means this is not a function. And another one, we have given a graph. Let us draw the vertical line. And since there is 1 point intersect on the graph, this is a function. Let us familiarize some of the graphs of basic functions. So we have first the linear function. Second, we have the absolute value function. And the third, we have quadratic function. So since we have 1 point intersect on this graph, so that means these are all function. And we have fourth one, square root function. The fifth, the cube function. Now, let us proceed on understanding the dependent and independent variables. How will you differentiate between the two? Dependent variable is the changes in response to another variable. That means this is our output value, while independent variable, that is determines the value of dependent variable. So this is our input value. Let us understand more about the dependent and independent variable by giving this situation. So Tom earns 600 pesos per day working at the restaurant. If he works at 7 days, he will earn 4,200 pesos. And if he worked at 10 days, he will earn 6,000 pesos. The number of days of Tom's work and the amount of money Tom's makes are related. Dependent variable, a variable that depends on or it's affected by the other values. And the independent variables, a variable that is not changed by the other values. Thus, the number of days Tom's work determines the amount of money. The amount of money Tom is paid is determined on dependent on how many days he works. So that means the amount of money is the dependent variable and the number of days is the independent variable. Let's have another example. So Joy sells ice cream for 10 pesos each. And we have the given two variables. The first variable, the amount of money. And we have the number of ice cream. So let us determine which is the independent variable and the dependent variable. So the number of ice cream determines the amount of money. So the number of ice cream is our independent and the amount of money is our dependent variable. Let's try more harder. Determine the independent and dependent variable given the equation. Consider this equation. Y is equal to 3x plus 6. So the value of y depends on the value of x. So that means y is our output value or the dependent variable and x is the input value or the independent variable. Let's have a table. So we have the set values of x or that is the input and y our output. So if we assign the value of x, wherein x is equal to 0, let us substitute 0 to the equation so we can know the value of y. So if x is equal to 0, y is equal to 3 times 0 plus 6, that will become y is equal to 0 plus 6. So y is equal to 0 plus 6 is equal to 6. And if the value of x is 1, let us substitute again 1 to the equation. Y is equal to 3 times 1 plus 6. So it will become y is equal to 3 times 1, that is 3 plus 6. and y is equal to 3 plus 6 is equal to 9. If x is equal to 2, so again, substitute the value of 2 to the given equation, y is equal to 3 times 2 plus 6. It will become y is equal to 3 times 2, that is 6, plus 6. So y is equal to 12. So the dependent variable depends on what the independent variable is.
Thank you everyone for watching. I hope you learned something new. See you again next time for another spectacular, comprehensive, and informative lessons. Bye-bye!